Okay, so hello. Today's problem of the day in the LeetCode is find elements in a contaminated binary tree. So basically, this is a type of design type of problem. Okay, we have to basically design a class where we have to design a function. Okay, that is bool function find. Okay, so this is related to basically binary tree. So basically the name suggests. Okay, so what we have to do is basically we have given a binary tree. So with the following rules. Okay, so rules are basically first rule, that is the value of the root will always be equals to 0, and for any tree node, if the for left node, if the left node not equals to 0 or null, sorry, okay, then we have to simply update the value with 2 into x plus 1. Okay, if the tree node value is x and tree node left is not null, and simply we have to update the value of the left with 2x plus 1. And in same, if the tree node value is x and the tree node right is not null, then simply we have to update the value with 2x plus 2 at the right. Okay, so this is the function, and we have this written. Then now the binary tree is contaminated, which means all tree node value have been changed to -1. So simply we have to implement the find elements class, and where find element is a constructor which basically initialize the object with a contaminated binary tree and recovers it. Okay, and there is a function find, and in function there is a target. We have to simply return true if the target value exists in the recovered binary tree. So let's understand what the question is basically saying. Okay, so here's I have taken this example. So basically, what is a contaminated binary tree according to the question? Contaminated binary tree is basically where all the values present, all the nodes values at the nodes will be -1. When all the values become -1, then it is simply become, it is a contaminated. Okay, so what the question is saying basically that this was the initial. Okay, this was the before contaminated this tree. Okay, this whole and after contaminated, it simply all the values becomes -1. Okay, after contaminated. So what the question is saying, that we have given this this whole, basically if I just adjust it, the whole this, okay, this we have given in the index. Okay, we will be given contaminated this tree. Okay, contaminated tree with all the values -1, and we have to basically recover it to initial. Okay, we have to basically recover it this. Okay, recover it to initial again. Okay, we have to basically recover it to previous to previous values. Okay, so that the values becomes the values becomes before contaminated values. Okay, so we have to basically recover it and then find the target. Okay, then simply we have to find the target and return true if the target value was existed before contaminated. Okay, so this so you have got the question that we have given this. Okay, basically we will get this, and basically we have to recover this in this. Okay, in this before contaminated thing. Okay, before contaminated, and when we recover, the values would be changed. Okay, so then we have to basically check if the target, that this function, this find function, if the target is present, basically it will simply take a target, and we have to simply return true if the target was existed, that is in this, if the target is in this before contaminated tree. Okay, so do you understand that what we have to do is basically we will get this contaminated string, and we have to simply recover it, and we have to just return true if the value is present in the recovered this tree. Okay, binary tree. So that's just how we will do it. Basically, if we see, this is this bool function, basically what we'll do, it will simply find the value. Okay, so simply it means that we will traverse this. Okay, traverse this binary tree. Okay, so for traversal tree we have two methods, that's BFS and DFS. Okay, so best method is basically DFS, that simply return answer or search the value fast. Okay, so because it checks value depth wise, so we will use BFS here to find the value when it is basically recovered, the tree is recovered. Okay, so simply we will find the value and we will return the answer, return true or false if the value was present in the basically tree. So the approach is basically using DFS. Okay, we will use DFS to traverse through the tree. So basically what is DFS? Let's understand. Basically DFS is visiting every node depth wise. Okay, so I have basically made a example binary tree. Okay, this is example. Okay, example binary tree where every node has some value. Okay, let's see if I have to find uh, uh, I have to find, let's see, 3. Okay, see, we have to find, not 3, we have to find, let's say 7. Okay, we have to find 7. Let's write find 7. Okay, so using DFS, how we will find it? So what happens is that it start with root. Okay, it simply go in depth. Okay, it simply go here and it will check this 3. Okay, is the 3 equals to 7? No, it will simply go again here at the depth and simply it's check the left index of left node of 3. It will simply check, is the value equals to 7? No, it will simply go, if basically it will simply, the right and left part of this 5 is basically null, so it will simply return to its parent node, and it will simply then again check for next right node. Okay, and then again it will simply check, is the value equals to 7? No, then it will simply return itself again, okay, to its parent node. So all the nodes at this 3 is visited, so simply it will return to its previous node. Then simply it will check for its basically next node, and it will simply check for this node and the value is there. It will simply return true and the value is present. If it was not present, it will simply check return here, and it will simply check for this, and then it will return again, and it will simply return here at last. And if the value is not present, it will simply return false. So this is how the DFS works. Okay, so basically what we will do, we will use DFS to search or traverse through the binary search tree to find the value. Okay, so let's see what we will do. Basically we will to store the, basically what we have to do is basically to store the values, we will use set. Okay, we will use set to store values. Okay, we will use set to store values, and we will basically, what we will do is we will implement a function. Okay, function that is DFS, where we will take the root, okay, and a value where a current value, or we can say value in the root, okay. So value of the root, that is we will simply say, first we will simply say it is 0. Okay, so first we have to basically say it is 0. Okay, simply we will create a function that is simply DFS, and we will simply initialize it with root, that is the root will be given in class. Okay, and simply we will put the value as 0 at initially. Okay, so what we will do is basically we will store. Okay, but if we see the conditions, what we have to do is basically at left node we have to store the value 2x plus 1, and at right node we have to store the value 2x plus 2. Okay, so what we will do, basically we will store every time this root. Okay, so set dot insert this root. Okay, we will first insert this value in the root. Okay, we will simply insert this value in the root, and then after we will simply recursively check for the right and the left node. Okay, so root left, and basically the value, what will be the value would be simply 2 star x or 2 star value plus 1, because at left we have to change the value with this, okay, and then recursively add DFS simply for right also, okay, for right node. So we will simply root left, root right, and 2 multiply value plus 2, okay. So simply what it will do is it will simply check for every left and right node, because basically what we have to do is basically, if we take the example, okay, so what we have to do is basically, if we take this, okay, this at, let's see how this will work. First it will simply it will hold this -1 and -1, okay, initially as, okay, initially it is simply saying that we will have a contaminated root, basically tree, and we have to basically change it, basically we have to recover it, and then simply we will have to return the true or false if the value is present or not. First we have to basically, what we will do is we will use this DFS function to recover it. How we will do is basically it will simply take this root, okay, this is basically root, so it will check, it will simply initialize it with 0. So how this whole thing will work, let's see here, okay. So first it will initialize it with 0, okay, so that's what we are doing simply, okay. It will simply initialize it with 0. Then here the value of the root, first initialization, let's write 0, okay. The root is simply 0, okay. So first it will make this 0, okay, and then it at let's just make whole tree, okay, and it has 2 second index, okay, and it is simply in -1, okay. So what it will do is it will simply go on, it will simply start the DFS root left to star value +1, okay. So simply it will come here, okay. It will simply, what will it will do is first it will set dot insert, it will simply take a set, let's make a set, okay. Simply it will start, it will store 0 as first value, okay. Simply it will store 0 as first value, and then we have written that DFS root left, okay. Simply it will check for left node, okay. So at one thing we have not written, that if the root in this function, if root equals to null, okay, so it will simply return, okay. The function will return itself, okay. So let's just make this function thoroughly, okay. It will simply this function, okay. So it will simply change the values, okay. Let's just fix this. So this is how the function, if this DFS function is basically construct the recover this recovered tree, okay. So simply what we'll do is it will simply first it will check root equals to null, no, root is basically with -1, it will simply return no, it will root is simply with 0, we have updated the 0, okay. So simply set dot insert, set will have 0 value, and then it will simply check for DFS root left, okay. So at here there is no, basically if we see that here it is null, okay. So simply it will call again this function, and it will simply be that this left is null, it will simply return, okay. So it will simply, what it will do is it will return from here to its parent node, and then simply it will go to this right node, and it will simply check for this, and it will update the value with what, 2 into value plus 2, and the value was 0, it will simply, it will be 2, okay. Not 0, it will simply be 2, and the updated, okay, it will simply, then again it will return, okay. Then the updated, this recovered basically is this tree, okay. This tree will be recovered, and one thing we have not done, that is 2 will also be stored here, okay. Simply, so this will be recovered value, okay. And at this function, that is find function, what we will do is basically at find function, we will simply in target, okay, we will simply, what we will do is we will simply return set dot count, okay, target, okay. If the target will be present, this count function return true or false if the value is present or not. It will simply return the set dot count, and it will simply check if the value is present or not, the target is present or not. It will simply return true and false. So this is the whole answer, okay. So you have got the thing that what we are doing, we are creating one more function, that is, and we are initializing a set, okay, and we are creating a function that will simply change the contaminated binary tree to the recovered tree, and then simply we will return the set dot count. We will take the set to initialize, basically to store the values, okay. So here I have opened the LeetCode, okay. So let's do, I will just solve with you, okay. So what we will do, we will simply first we will initialize a set, okay, set. So we have initialized the set that we can simply name that visited. So simply it will check that we have visited the root or not, okay. So basically it will store the values, okay, total. And in this we will create a function that will simply DFS function, that is simply give the root and initialize the value with 0, the root value, okay. And simply we will create a DFS function that will simply take this root, okay. At first let's just write it properly, star root, okay, and then it will simply take a value, okay. Simply it will write int value, okay. And then after, first what it will do is it will simply check if the root equals to null, because if the root is null, simply return, okay. And if the root is not null, simply it will simply store first in set visited dot insert, okay. What will do, it will simply store value, okay. And then it will simply call it again for left and right, okay. Root left, or the value would be, what would the value, 2 star value plus 1 for this left, okay. And the same thing is for right, but only the value will be changed, okay. So what will the value for the right, it will simply 2 multiply by value and plus 2, okay. Simply it will simply create the recovered tree recursively, and then we have to simply find, what we'll do, we will simply return visited dot count and target, okay. It will simply return the, okay, let's just correct it, okay. Simply it will return the true or false, okay. Let's run it. So I have just, okay, I have basically a spelling mistake, okay. So let's just check it. So what we have done, okay, I have not written here the returning, it will simply void, it will simply create the, it will change the tree, okay, tree to recover tree, okay. So simply it will working fine. So let's just submit it. Yeah, it was simply working fine, okay. So